Welcome back. So our Stable Diffusion demo built with Gradio returns some outputs here. I'm not sure what's going on here, but this model works by scraping the internet worth of images. I think this is on the Lion 5 billion data set, and then maps those images to sort of text. And then when we feed in text, it tries to create an image with that text in mind. So there's not much machine learning going on here. From my point of view, there's a lot of chefs, so still room for improvement, but it's pretty cool that this machine learning model can just create an image given some text. So how about we go steak dinner? That would be cool if our classifier can work on this image. I'm gonna let that run in the background, but this is what we're working towards, Food Vision Mini, deploying it something like that. I've just linked that here. And let's give a little quick overview of Gradio. We've done that, but I'm just gonna type it out for completeness. Gradio helps you create machine learning demos. And the reason why we want to create a demo, is so other people can try our models and we can test them in the real world. So remember, deployment is as important as training for machine learning models. If you really want to test them, numbers on a page within the sterile environment of a notebook are very nice, but until you get it in the hands of others, that is the real test data set. And finally, so the overall premise of Gradio is to map inputs, function/model, outputs. And of course, I've got these details here in the Learn PyTorch book. So yeah, inputs, ML model, outputs. And in our case, what we want to do with Food Vision Mini is go from images of food to FNetB2 to outputs. So this is the model we've chosen to deploy because it fulfills our criteria the best. But your inputs and outputs could be any combination of the following. That's how flexible Gradio is. You could have images, you could have text, video, tabular data, audio, numbers, and more. I haven't listed them all. They are, of course, in the documentation. So let's keep pushing forward. What do we have to do now? Well, we've got our inputs, function/model, and outputs. We know them. We know our ideal inputs, food images. We know our ideal model to use so far is EfficientNet-B2, and we know our outputs are some form of label, such as steak, sushi, or pizza. And of course, prediction time for fun, why not? So what we have to do is create a function to map our inputs and outputs. And this is what we're going to be feeding to our Gradio interface class. This is the main class of Gradio, which is gradio.interface. We're going to get hands-on with this later, but it has a few main parameters. Function, so fn, which is a callable Python function. Inputs, what are your inputs to your function? So in this case, it's an image input. And then what are the outputs? And there are a few more here that I'll let you explore on your own, but we're going to focus on creating a function, defining some inputs, and defining some outputs using the interface class. So let's keep going. We want to create a function. First thing we're going to do is put our model on the CPU. Just to make sure that it's there, we're going to hard code it to the CPU, Now, why are we doing that? Because when we deploy eventually to Hugging Face, this system, unless we explicitly pay for it, is going to run on the CPU. So that's why we want to explicitly hard code our model to the CPU so that it runs on the CPU. There are options to upgrade to GPU, but that's an upgrade. So I'll let you look into that if you want. And then we're going to go check the device. So next, we want FNetB2 parameters. Let's just make sure that the parameters are on the target device, CPU. Beautiful. And so now what we want to do is, I'm going to write this down. Let's create a function called predict. You can call this whatever you want. To go from, we want images of food to ML model, which in our case is FNetB2. FNetB2. And then we want our outputs, which will be food class label. This is what we want our predict function to do. And that will be what we feed to the Gradio interface class as our FN parameter. And I'm just going to get out of this one, clean up our tabs a little bit. So let's start off. I'm going to import from typing, import tuple and dictionary format. So a tuple, recall, is just tuple example equals 224, 224. That's just a tuple, something like that. So let's go. We're going to create the predict function. It's going to take in an image because that's going to be the input. Images of food. And it's going to return a tuple that is a dictionary and a float. Now, why is this? So I actually want two outputs here. Food class label and prediction time. Why are we doing that? Well, of course we want the classification label, but we want the prediction time. Like all good cooking shows, I've already got one of these demos working. The prediction time is going to help us evaluate how fast our model predicts on an image in the real world. So if we click on this example, see, that's pretty close to real time, 0.03, not exactly there, but it's pretty close. So subsequent versions of Food Vision Mini, we'd probably want to try and get this down towards real time. But as you can see, this is working pretty quickly. Then if we clear it, we upload another image. How long does it take? Now this one takes a little bit longer because we have to wait for the network time. Network time means we're uploading this image to be queried on a model that's hosted on a server. So the prediction time is actually quite quick. So let's push forward. What do we want this function to do? We want to start a timer. We want to transform the input image for use with FNet B2. I'm going to put these as headlines and then I'm going to give you the challenge of trying this out. So put model into eval mode, make prediction, and then we want to create a prediction label and prediction probability dictionary. So that's what we want to return. That's going to be our Gradio outputs. So this is actually a dictionary here. It's just been formatted nicely to look like that. So the kind of dictionary that we want is predict, or we'll call it pred labels and probs. This is just an example. So steak, and then pred prob for steak. And then we want pizza, and then we want sushi to follow that same format. So this is my challenge to you. And then finally, we want to calculate pred time and then return predict and pred time. So let's call this return pred labels and probs and pred time. Beautiful. So this is the function we're going to work towards creating. It's going to be this little insider part here. If we go back, this is what's going to map our inputs to our outputs in our Gradio demo. Very similar to this, but different logic in the function there. So give it a go filling in these comments with code, and then in the next video, we'll do it together. I'll see you there.